In this first module of the appendix, Module A1, I define information design, briefly discuss the concepts involved in visualizing data, and give an overview of 12 of the major graph types used in science. Information design is the practice of presenting information in a way that fosters efficient and effective understanding of it. Design and visualization is a requirement, not a cosmetic addition. Visualizing data. What needs to be emphasized, for example, the mean of a set of numbers, and what additional information needs to be included, for example, the standard deviation and range, depends entirely on the message to be communicated. As a rule of thumb, bar and line graphs are useful for comparisons, scatter charts as well as line and bar histograms for distributions, scatter and bubble charts for relationships, stacked, 100% stacked, area and pie charts for composition. Here I provide overviews and best practice concepts for the most common graphical displays used in biodemography, noting that no graph can necessarily be considered good or bad, only more or less effective. Here's an overview of the 12 different graph types that I will cover in detail in this module. The first graphic category I will cover is bar charts. Bar charts are used to show change over time and thus should run left to right. Three variations of the basic bar chart include stacked bar charts that are used when you need to compare multiple points to the whole relationship, 100% stacked bar charts that are used when the total value is unimportant and the percent distribution of subcategories is the primary message, and multiple categories side by side that is used when comparing values in different categories, for example, trends in male and female marital rates across decades. Bar charts are popular because they are easy to read by comparing the endpoints of the bars. Design best practice guidelines include show change in time, horizontal option, use horizontal labels and not vertical ones, spacing 1/2 bar width, start y-axis at 0. The next graph type is the dot plot. The dot plot may be thought of as an adaptation of the scatter plot for use when the vertical axis variable is categorical. Dot charts may be considered as replacements for bar charts. This is because they allow for more effective visual decoding of quantitative information and can be used for a wider variety of data sets. A histogram is a graph that uses bars to display a distribution. It differs from a bar chart in two respects. First, a histogram is used for continuous data in which the entire range of values is divided into a series of non-overlapping intervals, whereas a bar chart depicts values for categorical data. Second, unlike a bar chart where the bars are separated, the bars in a histogram are contiguous. In other words, there is no white space between the bars. The best practices for constructing histograms are, they are applied to continuous data, the data are displayed in bins, the bars are not separated, and use vertical bars. Scatter plots show the relationship between items based on two sets of variables. They are best used to visually show correlations within large data sets when the data are encoded simultaneously on the X and Y axes. Design best practices include start the Y-axis values at 0 if at all possible. Use lines to draw attention to a correlation between the variables to show trends. Bubble charts are good for displaying nominal comparisons or for ranking relationships. Bubble charts can be used instead of scatter charts if the data have 3 data series that each contain a set of values. The sizes of the bubbles are determined by the values in the 3rd data series. Best practices include make sure labels are visible, size the bubbles appropriately to make them scaled according to area and diameter. Do not use odd shapes like triangles and squares, since using shapes that are not entirely circular can lead to inaccuracies. Area charts depict a time series relationship, and they are different from line charts because they represent volume. There are 3 different variations of the area chart. The standard area charts that are used to show or compare quantitative progression over time, stacked area charts that are best used to visualize part-to-whole relationships, inasmuch as they also help to show how each category contributes to the cumulative total, and 100% stacked area charts that are used to show distribution of categories as part of a whole, where the cumulative total is unimportant. Best practices for area charts include stacked area charts should be arranged to position categories with highly variable data on the top of the chart and data with low variability on the bottom. Start the y-axis value at 0 because starting the axis above 0 truncates the visualization of values. Do not display more than 4 data categories because too many categories results in a cluttered visual that is difficult to decipher. Line charts are used to show series of continuous data. For example, time relationships including trends, accelerations and deceleration, spikes and troughs, and overall variability. Although line charts can be used for demographic data that is either categorical or discrete, they are especially appropriate for visualizing continuous demographic data, such as population rate trends, such as births, deaths, and growth. Best practices guidelines for line charts are include a zero baseline if possible, because this provides an important frame of reference. Use a maximum of 4 or 5 lines because more lines, i.e. so-called spaghetti charts, are difficult to interpret. If more lines are needed, then create 2 charts or a panel of charts, each with a single line. Only use solid lines because dashed lines are distracting. Label lines directly to reduce or eliminate the need for a viewer to visually dart back and forth between the legend and the lines. A box plot is just a bar that encodes a range of distribution of values from one end of the bar to the other. The middle of the box plot is a horizontal line that divides the box into 2 to mark the center of the distribution, which is usually the median. There are 2 lines called whiskers that encode additional information about the shape of the distribution. One line extends upward from the top of the box, and the one extends downward from the bottom of the box. The full set of information that is presented in a box plot includes highest value, lowest value, range, median of the distribution, range of the middle 50% of the values, mid-spread, that is a value at or above which the highest 25% of the values reside, 75th percentile, and the value at or below which the lowest 25% of the values reside. Heat maps display categorical data using intensity of color or shades of gray to represent values or geographic areas. Design best principles for heat maps include use a simple map outline, use a single color with varying shades, exercise caution with colors such as red that can stand out and thus give unnecessary weight to the data. Choose appropriate data ranges, for example, 3 to 5 numerical range that facilitates an even distribution of data. Strip plots can be used to display and compare multiple distributions. Strip plots display each value in the data set rather than aggregating the number or percentage of values into intervals. Although strip plots also clearly show the shape of the distribution, they are especially useful when you have a small set of values and wish to show precisely where each value falls along a quantitative scale. There are 2 ways to make points visible if they are located on the exact space. Jittering, so they are repositioned, that is vertically stacked, and then making a data point transparent, that is open rather than closed circles. The last chart I cover here are pie charts. They're best used to make part-to-whole comparisons. One argument against the use of pie charts is that it's difficult to gauge and thus compare the sizes of the different slices. Design best practice guidelines include use no more than 5 categories, avoid tiny slices since they become lost, do not use multiple pies side by side because it's difficult to compare slice size between pies. Order the slices correctly by placing the largest segment at 12 o'clock, then order the remaining slices in descending order counterclockwise. This ends this first module of the appendices involving the different basic graph types for visualizing data. I will close by quoting from the book on information design and graphics by Stephen Few, titled "Show Me the Numbers." When a chart is properly presented, information just flows to the viewer in the clearest and most efficient way.